Using our criteria for polar and nonpolar molecules, determine whether each molecule on the slide is polar or nonpolar. Molecule A has a hydrogen atom bonded to a carbon atom, which is triply bonded to a nitrogen atom. Molecule B has a carbon singly bonded to 3 hydrogen atoms and singly bonded to 1 oxygen atom, which is then bonded to a hydrogen atom. Molecule C has a carbon atom singly bonded to 3 hydrogen atoms, and the carbon is also singly bonded to a fluorine atom. Molecule D has carbon singly bonded to 4 hydrogen atoms. Pause the video to determine which molecules are polar and which are nonpolar. Remember that the criteria for a high symmetry molecule is that there are no lone pairs on the central atom and the outer atoms are the same element. Looking at molecule A, the carbon atom is bonded to 2 different elements, hydrogen and nitrogen, so this is a polar molecule. Since nitrogen has a higher electronegativity than carbon and hydrogen, the delta negative symbol is placed near the nitrogen, and the carbon-hydrogen part of the molecule is assigned a delta positive symbol. For molecule B, the carbon atom is bonded to 2 different atoms, hydrogen and oxygen, so it is a polar molecule. Since oxygen has a higher electronegativity than carbon and hydrogen, the delta negative symbol is placed by the oxygen, while the delta positive symbol is placed by the part of the molecule that has carbon-hydrogen bonds. Molecule C is polar since carbon is bonded to 2 different elements, hydrogen and fluorine. The delta negative symbol is assigned to the fluorine atom since it is the most electronegative atom, while the delta positive symbol is assigned to the part of the molecule that has carbon-hydrogen bonds. Molecule D is nonpolar. Carbon has no lone pairs and it is bonded to 4 atoms of the same element, hydrogen. Let's look at one more example. On the slide is the Lewis dot structure of sulfur dioxide, where sulfur is double bonded to each of the 2 oxygen atoms, and there is 1 lone pair on the sulfur atom. In sulfur trioxide, the sulfur is singly bonded to 2 oxygen atoms and has a double bond to the 3rd oxygen atom. In sulfur trioxide, there are no lone pairs on the sulfur atom. Pause the video and identify the polarity of these 2 molecules. Since the sulfur atom in sulfur dioxide has a lone pair, this is a polar molecule. On the other hand, since sulfur trioxide has a sulfur atom with no lone pairs, this is a nonpolar molecule since the sulfur is bonded to 3 atoms of the same element,